it going, guys? We're going to go over some calculations for molar mass when there is a compound. So let's just start off with this one. Al2 CO3 3. So that is aluminum carbonate. That's from our previous problem, actually. And let's see how to calculate the molar mass. So the way I like to do it is, first off, calculate how many of each element we have. So list out each element. Al, we have carbon, we have oxygen. Only 3 elements, that's not too bad. So we know we have 2 Als. Then for carbons, we have 1 in here, but then 3 of this in total. So that's 3 carbons, because we can put that through there. Then we have 3 oxygens inside here times 3. So just do 3 times 3. That's going to equal 9. So now we can consult the periodic table to figure out what the molar mass of each one is. So for aluminum, let's see, it's right here, 26.98. We can round that up to 27. 27 times 2. So for Al, for C, and for O. For carbon, we have right here 12.01. We'll just do 12 for the sake of this problem. 12 times 3. And then oxygen. Oxygen, we have 15.9994. We'll round that up to 16. 16 times 9. Now we'll just get out the calculator and do some old-fashioned arithmetic. 27 times 2 is 54. 54, and then we have 12 times 3, 36, and then 16.9, or 16 times 9 is 144. Now we're just going to add those up. 144 plus 36 plus 54 equals 234. So that is the molar mass of this compound. Now we're going to do, let's see here, MgC2H3O2. 2. Again, we're going to look at how many we have of each element, but remember to distribute this 2 into the bracket. So let's see what we got for elements. We have Mg, we have carbon, hydrogen, and oxygen, just 4 elements. So we have 1 magnesium, we have carbon, so we have 2 inside, and then we have a 2 here. So 2 times 2 is 4. We have 4 carbons. We have 3 hydrogen inside, 3 times 2 is 6. And then we have 2 oxygen inside, 2 times 2 is 4. And we'll just go back through just like we did for the last one. MgCHO. So for magnesium, let's see what that is. 24.3. We'll just round down to 24 times 1. 24. Now for carbon, we have 4. Up here we wrote 12, so we'll do 12 times 4. Then for hydrogen, we have, let's see, should be, it's 1.0079, so we'll just round it down to 1. 1 times 6 equals 6. And then for oxygen, we have 16 times 4. 64 plus 48 plus 6 plus 24. 142. The exponents are pretty much the only things, they're pretty much the only thing that can really throw you off if you don't understand, like, basically how to distribute into a fraction. That's something you got to watch out for. We'll do another one that I actually got on a test one time. Carbon 2,952. Hydrogen 4 4,664, nitrogen 812, oxygen 832, sulfur 8, and iron 4. This is the formula for hemoglobin. And we do it just like all the other ones. I mean, it's actually even easier technically in terms of the math, because we just we don't even really have to worry about the exponents and making sure we have the right amount. But the tricky part here is there's just so many bigger numbers that we have to basically be careful that we don't trip over our own calculations. So here we have carbon, it's going to be 12 times 2,952. Then hydrogen is just 1 times 4,664. Nitrogen, did we have that? Nope, that's over here. 14. So we have 14 times 812. Then we have oxygen, which was 16 times 832. Sulfur, what was that? 32. 32 times 8. Then iron, where is that? Right here, 55.8. We'll round that up to 56 times 4. 12 times 2,952 is 35,000. This is just going to be 4,664 because it's only times 1. Now we'll do 14 times 800, yep, and then we have, what is that, 11,368. Then we have 16 times 832, that is 13,312. Then we have 32 times 8, 256. And 56 times 4, 224. Just add those up. 35424. Oh, 35424 plus 4664 plus 11368 plus 13,312 plus 256 plus 224 equals 65,248. That should be grams per mole. This should be the molar mass of hemoglobin. Hopefully you can read that. So yeah, again, with these big ones, it's really just a time sink. If you're pressed for time on a test, that's going to be something that's going to be difficult, but if you rush, then you're likely to make some kind of mathematical error. So just watch out for those. Yep, I hope this helps someone.